Okay, so first of all, I'm going to open a PowerPoint to go over a few slides. Okay. All right, so we'll use PowerPoint along with so we'll probably do a whiteboard to explain your homework questions first, and then we'll do PowerPoint a few slides to introduce few basic concepts, and then we'll do data model, not data model, SQL developer to write SQL statements. Okay, so let me start with PowerPoint slide show. Okay, beginning. All right, so here for the first one is a homework review. So you'll have homework question. The very first one was to create ERD for clinic to keep track of its patients, appointments, doctors, and visits, and then convert the ERD into relational model. Perfect. So we're going to use this as an example to review forward engineering. So first of all, based on the problem, we identified that patients as objects, you need to keep data. Appointments is like concepts, right? So that's also important. You want to keep data for appointment. Typically, we'll have like appointment date, right? And then appointment reason why you make appointments, right? Doctors, of course, you make appointments with doctors, right? So doctors is important. And the visit is not the same as appointment. You understand that, right? A visit is more like a treatment, right? So you make appointment first, and then you may go or may not go. So after if you go to the clinic and you receive treatment, so you can just interpret that as treatments, right? So a visit has like a visit date, some related things, right? So when you take a visit, when you go to visit, and then you're going to, the nurse is going to going to take you like a vital signs, right? So, and also you're going to get a prescriptions, all that, exams, all that, right? So visit, of course, is very important, but I'm not going to explore many different phases of visit. This is a very complicated thing. So if you, this could take you many hours to understand how to conceptualize a visit. So we will just simplify it as just a regular object, okay? And also we consider like a vital signs as a side thing for the visit only. All right. And then after we have the ERD, then we convert it into relational model. So let's do that using whiteboard. Okay. I'm going to add. Let's create a new whiteboard. Okay, so let's get started. So let's just we'll use whiteboard to conceptualize. So you can do that using the data model, but that takes a little bit more time. So I'm going to just do it in the whiteboard. Okay. So first of all, let's just say conceptualize these objects. Those objects are already pretty much conceptualized for us, right? So we have patient. All right. And then patient, let's just say patient have patient ID, which is identifying attribute. And the patient may have like a name, okay? So you might want to differentiate the first name with last name, decompose it, okay? And then let's just put one more thing. Let's say patient has a phone number. All right. And then we have doctors. Doctor have employee ID, employee last name, and then field of expertise. So let's make all of them as a required attribute. And then we have appointment. Okay, just say appointment has appointment ID, AID, and appointment date. Say required. And then let's say reason for the appointment. Okay, and then let's say visit. Okay, visit, we can say we have a visit ID as identifying attribute, just make up something. And the visit date, okay, which is maybe required. And I said the visit has a lot of things like prescriptions, tests, all that, okay? So let's just do one simple thing, which is called vital signs here. Oh, by the way, that is not required for your homework grading. So when I do grading, I will not consider this. I will consider only these 4 basic objects. So now let's say, suppose I need to handle different kind of medical records associated with a visit. One type of records will be vital signs, right? So vital signs, of course, is you can have like a blood pressure, like high pressure, low pressure, and then heart rate, right? And then what else you may have. So those things, will be typically, have some kind of, like I say, high pressure name and also value, pressure name value, right? So each visit, you're going to have multiple of those. So that should not be treated as simple variable. So you should treat that as a more complex variable. So I'll treat that as a weak entity here. Weak entity, okay? So for each vital sign, you're going to have VS number. So vital sign number 1, vital sign number 2, vital sign number 3. So basically the vital signs do not have a UID by itself, because there's 1, 2, 3. Each visit, you're going to have 1, 2, 3 vital signs, right? And then, so that vital sign has to be associated with a visit to be uniquely identified. So that's a weak entity. Okay, so that will make this a partial ID. And then name, VS name, say, let's say high pressure, okay? And the VS value, say what is high pressure value, right? So let's just say 140, okay, or 150. So those are the actual value. So you can have a list of those vital sign, name, and the values, and that will be attached to each visit. All right, so that, and other medical records like prescriptions and exams, all that could be just kind of follow that to be extended. Okay, but I'm not going to do further than this one. All right, so any questions? If not, let's say how we are going to connect this, right? So apparently, patient and the appointment should be connected, and that should be what? One patient can have many appointments, right? So that's one-to-many relationship, and the patient, each appointment is going to be for one patient only, right? And the patient may or may not have an appointment, so this side should be dashed. Okay, so I'm going to use dash line for this one. Okay, but the appointment, if you have appointment definitely will be for patient. So that's, this side is solid. All right. And then the patient, of course, is going to, the appointment is going to with doctors, right? So you may have, say, I want to make appointment with a doctor, and the doctor, so appointment is, the doctor has the appointment is for doctor, whatever. So then this relationship should be also one-to-many. One doctor may have many appointments, right? But one appointment is for one doctor, right? So that's usual case. But a doctor may or may not have appointments, so let's say make this dashed, okay? All right, and then what? Visit. Of course, patient pay for visit. So let's just make a connection between patient and the visit. Okay, and that is also one-to-many relationship. Apparently, each visit is for one patient, and one patient can have many visits. But that is also dashed. because the patient may or may not have visit. All right. And what about the doctors and the visit? That relationship, of course, doctors, handled visit, right? Doctors handle the visit. So visit, you understand, is more like a treatment. So usually each visit will be handled by one doctor. So if you're dealing with a primary doctor, that would be just one, okay? So each visit you have one primary doctor. But if you're dealing in general case, like in the hospital situations, each visit may be handled by multiple different doctors. So in that case, you can have a many-to-many relationship. Okay. Each doctor can handle many visits, and each visit can be handled by multiple doctors. So that's many-to-many relationship. Okay. Now, can you think of any other relationships? So let's say appointment and visit may have one-to-one relationship, right? Because each appointment may result in a visit because of the appointment, right? But appointment may or may not have been realized. So this side may be dashed, okay? So appointment may or may not have may or may not result in any appointments, any visit. So let's just add. Okay, so this side is dashed. All right. Any other thought about this relationship? I think some of you might think, what about doctors and patient? Patient see doctors. Should you connect doctors with patient? What do you think? Should you connect patient with doctor?
Yes, I think because doctor has patients, right?
Doctor has a patient. In what sense doctor has a patient?
Like each doctor can have multiple patients. Like each doctor can be treating multiple patients, right?
Trading. Okay, so if you're doing trading, then basically each treatment will be recorded here. So that visit is just like a verb action, which will be cut in the middle between doctors and the patient.
It'll be just like an entity in the middle that will be connecting both.
Yeah, because so if you interpret that doctor sees patient or patients see doctors, then the see, the verb is converted into visit, right? And that is like what we had before, like a customer buy products. So we make a purchase in the middle, right? So that
it's
is
like a weak entity in the middle.
not a weak entity, just like a verb. So this is a verb action.
Okay.
This is action words. Okay, so we need to have data on those actions, right? So that's a visit. So remember when you say the doctors treat patients, so basically that's the treatment here. All right, but you do have one situation that doctors and patients may be associated directly. That is in some insurance situation like HMO, I believe. Each patient will be assigned with a primary doctor. So no matter what disease you have to see your primary doctor first. You do not have flexibility to change to different doctor, for example. Okay, but if you do want to change it, then you have to change it permanently. So that basically in a database, if I want to keep track of that assignment relationship, then that relationship may be recorded here. So each doctor may be assigned with multiple patients, okay? And then each patient is assigned with one primary doctor. So that relationship is assignment. And that is different from visit. It's not the same as a visit. The visit is just say, each time, only if you have visit, you have relationship with doctor and the patient. If you do not have visit, then there's no relationship, right? But here, this relationship is more like a reflecting the assignment, the HMO, for example, with assignment relationship. The patient is assigned to that one primary doctor, okay? So whatever disease you have, you look at that primary doctor first. For like references or whatever. Okay, so that is possible if you consider that, but has So if you say doctor has a patient, that is pretty vague. It's not, the meaning is not very clear. Okay. So if you say doctor see the patient, then we already have C. Doctors treat the patient, we already have a treatment here. So that will not be necessary. All right. So now, any other question you may have? So if you don't, then let's do one more time, say how can we convert this into relational model. So basically that's pretty mechanical thing. So we will create like a 5 boxes first, right? So patient's box. So name that as a patient, okay? Table name will be in the plural form. So patient ID, I use underline for primary key, and then P name, that's required. And then phone, that is optional. And then we have doctors. Doctors have employee ID and the last name, which is required. And then we have a field of expertise, that is also required. Okay. And then we have appointments. So appointment have appointment ID field, appointment date, just say that is required, and appointment reason, that's also required. And then we have a visit. The visit have visit ID, VID, and the visit date. Okay, so that's required. And then we have one more box for vital signs. Let's do it here. Vital signs. So that a vital sign number, which is not a primary key by itself. Okay, it's only partial primary key. And then we have vital sign name and a vital sign value. So they both are required, I believe. Okay, so that is just step one, the rule number one, you convert each box into a table. Attributes become columns, identified IDs become primary key or part of primary keys, and also indicate whether each column must have a required value or no optional value, okay? And then we need to handle relationships. So the first thing, before you can do any other relationships, you need to handle weak entities. That's always the order you need to follow, okay? So we handle this weak entity. So the way to handle this weak entity, it depends on the visit, okay? So between visit and the vital sign, it has a one-to-many relationship to begin with. So we're going to duplicate the primary key of visit into vital sign, okay? So on the vital sign, I'm going to duplicate this VID in here. So we can call that VID, or we can just use another name, say visit, okay? And that is just essentially same as a VID, but I just change the name, okay? So that is how we make that connection. Now this VID is required because this side is solid, okay? It's for weak entity is always required, always, okay? So, all right, and then to handle this little bar, we just need to make sure that the primary key duplicated from this strong entity into here as a foreign key, right? But also as part of a primary key. So we have to underline this. So remember this. This vital sign now has a primary key consists of 2 columns, VS number and also visit. Okay, so this composite primary key. Now after this weak entity is handled, so if you have other weak entities, then you have to handle those first, okay? And after that, now we are ready to handle any other relationships. So let's do one by one, okay? Don't forget any. So let's say between patient and appointment is the one-to-many. So patient ID is going to be duplicated inside appointment, and that foreign key is going to be required because this is a solid, right? So receiving side is solid. So let's do appointment. Okay, so appointment, I'm going to put, let's just put patient ID in here. Patient ID, or we can just name that as patient. We can rename, okay? So that is a foreign key, and that is required, and it's going to be connecting to this one. Okay. Make sense? So primary key from patient, duplicating in here as a foreign key. So we handle the one-to-many relationship. And now let's do the same thing, patient with visit. Pretty much the same thing. So patient has patient ID should be duplicated inside the visit. And also the visit is, and also that is required. So let's do it, make it here. So let's just create a patient here. Okay, and there's a foreign key, and that is required foreign key. And we draw, if we want to draw a line here, that would be line crossing from here. Okay. So that's one-to-many relationship handled. Okay, next let's handle relationship between doctors and the patient here. So this, this patient is associated with doctor, right? Let's handle that. So in that case, we have one-to-many relationship between doctor and the patient. Okay, and then we need duplicate primary key of doctors into here, into patient. So we will need to create duplicate inside the patient. So we can call that as, say, primary doctor assigned as foreign key. And that foreign key depends on whether it is optional or not. So let's just do, according to what we have drawn here, each patient will definitely have a primary doctor, and each doctor will definitely have a patient. So both sides are solid. So then this side is solid, receiving side is solid. So therefore, you're going to make that as required. So it means that the column cannot have missing values. Okay, primary doctor column. So we handle all the relationship with patients. So now let's do that with doctors. Okay. So doctors associated with patients, we already handled that. And now doctors associated with appointment. So that's a one-to-many relationship. Again, so we're going to duplicate the primary key from doctors into appointment. So let's do that. And also this is solid, receiving side is solid. So I'm going to duplicate the primary key into appointment here. So let's just say doctor, okay, as a foreign key. And that is, somehow we have to cross this line. Okay, and that is required also because the receiving side is required. Okay, so now this relationship is handled. And now let's say doctor with a visit. That's a many-to-many relationship. So therefore we need to create a junction table in the middle between doctor and the visit. Okay, so let's just do it somewhere here. Okay, so doctor and the visit, let's create that empty table first. So I'm going to duplicate the primary key from doctor. So that would be employee. So let's just rename that also. That's doctor. That's a foreign key. Okay. And then visit, primary key for visit is a visit VID. So I'm going to just rename that also. That's a visit. Okay. And for junction table, all foreign keys will be required. And also, let's just take a simplified approach so that all foreign keys will make up a composite primary key for that table. So the junction table is going to have two foreign keys and one primary key consisting of two columns, doctor and visit. Okay. What about names? How do we name this junction table? If we can find a descriptive name, so this basically just handle. So basically is what doctors handle the visit, right? So you can find a descriptive name. If you cannot find it, you can just use simple combination of both original names in the table of the original tables. So doctor visit. So let's say doc visit. something like that. Okay, so as a name, so combination of that will make that junction table's name. Good. So now let's go back again. So we handled all the relationship with doctors, that, and that, right? Okay, so I think we are pretty much done. So now we have appointment and visit here. That's a one-to-one relationship. So you could do either way. You could just duplicate primary key from visit into appointment, or appointment into visit, either way. Okay. So let's just say I will duplicate primary key of visit into appointment. So in that case, receiving side is dashed, so the foreign key should be optional, right? So we will do, let's say what do we do here? We will go to appointment here. So create a column, maybe called a visit as a foreign key, and that is optional, and that is duplicating this one, this VID. Okay, so that is one way. So we duplicate primary key from visit into appointment. So that way we can look at appointment table to see whether the appointment result in an actual visit. Okay, if it does not have a value of visit, that means that appointment is just made without showing up. Okay, without showing. Good. So I think that's it, right? That's all. That's everything. All the relationship we handled. Okay, so this is the result of the relational model. Any questions?
Professor, are the lines connecting the keys required, or do we simply just need to put the keys in?
No, not required. Not required. Just a way to show the relationships. If you do not have those, but just make sure that you duplicate primary key into foreign keys correctly, and that's all we need.
Thank you.
Yeah. Any other questions? If not, let's go back to the PowerPoint. I think you have 3 questions. Other 2 questions were primarily just forward engineering, right? So this question has both ERD and the relational model. Okay. So now if you have questions for other questions, you can we can talk about those later. But if not, I'm going to move on to PowerPoint. Okay, so we did that, and I'm going to skip forward engineering reviews. Basically, those are 3 things, right? Depending on cardinality. So this is something you need to just kind of like build that as your second nature. Always know that if you have one to many, duplicate from one side to many side. Many to many, create junction table. One to one, duplicate primary key for any side to other side. So remember that. And then regarding those, whether those foreign keys should have a required value or an optional value, that depends on the receiving side, whether the receiving side is solid or not. And foreign keys in junction table will be always required. Okay. And then with weak entities and associative entities, just only thing you need to know that when you have that little bar, then you have to make sure that foreign key duplicated will become part of a primary key for the weak entity table and also associative entity table. Okay. So, and then when you need, for example, duplicate the primary key from the weak entity table to another place, just remember you have to duplicate all key columns, okay, not just the original ID column. All right, this is what we did. I'm going to just skip those. This is what we did in the last class, and then okay. So now let's talk about SQL. SQL is a programming language. It stands for structured query language. And this language is unlike other programming language like C++, Java, C#, Visual Basic, there maybe are some other languages. That this language has 2 distinctive features. One feature is that it's non-procedural language. Okay. And that is, so other languages like Java, C++, all those pretty much all procedural language. So what's the difference? The procedural language, basically you have to lay out the logical steps one by one to reach to your target. So for example, if I'm going to program a robot to move from that corner to that corner, what I have to do is I have to tell the robot to say, first of all, you move 3 steps forward, and then turn left, two steps, and then move forward 5 more steps, and then turn left, turn right 3 steps, something like that. Okay, you have to lay out the steps one by one, and then eventually there's after following those steps, then your target is going to be reached. So that's a procedural language. What about non-procedural language? Non-procedural language is actually doing you do not need to specify the logic. You do not specify what is how you perform the steps. Instead, you tell your robot, say your target is that corner, okay, and then you need to find your own way to reach the target. Okay, so it's more like a goal-specific language. Goal-specific language. So you specify the goal, specify the target. Okay, so the difficulty with the non-procedural language is you have to precisely specify what is target, and then the machine. So in our case, the DBMS, database management systems, will find is a way to execute your command, and then describe how to find the target, how to reach to the target. So in the robot case, the robot will basically have to find its own way to reach the target based on what you want, your goals, the specific goal. Okay, so SQL is a non-procedural language. So in that sense, it might look, for beginners, it may look simpler than more sophisticated programming language like a C#, like a Java, right? However, after you reach a certain level, so we are going to, we probably will have like a 2, 3, 4 weeks of SQL. Toward the end of that, if we realize that you would rather do a procedural language instead of a non-procedural language, because sometimes specifying the target is not easy, okay? Because that could cause confusion, could cause ambiguity. So we will have exposure to that. So for beginners, for the beginning part, is easier than programming language. But for more sophisticated requirements, then SQL may not be as simple as a procedural language. The second feature for SQL is it is a 4th generation language. Okay, so in terms of generation, with the 1st generation language in 1950s, 60s, we have a computer. There's a big giant computer, like a house, like a building, right? And at that time, we programmed the computer. It's basically just speak machine language. Okay, so you use machine code to use machine understandable language to write a code. So that's a machine level language. Okay, and of course that because we understand the machine basically just speak zeros and ones, and we human beings speak English, right? We do not, so there's a inherent, kind of a conflicts, inherent incompatibility between machine and human beings. So the 2nd generation language is slightly more programmer friendly. It's called assembly language. So I think assembly language is still alive. If you study computer science, I believe that there might be a course called assembly language, so you can actually learn that. So basically, assembly language, basically you deal with memory content. So for example, move X to Y, this kind of instructions. So basically, you're dealing with pretty low level instructions. Okay. And the 3rd generation language is more common. So basically, most languages that we're talking about, like Java, C++, C#, C, Visual Basic, 3rd generation language. And this language has a feature of machine independent. So you can write the same kind of code for Windows computer as for like a Mac computer. Just different kind of machines, different kind of Windows. You can just write it using the same kind of like a code. Okay, so it does not depend on the machine, does not depend on the CPUs, and also it's more programmer friendly. It's not programming friendly. It's programmer friendly, basically because the code we are going to write is pretty much is cryptic, is very simple, but it's still English. Okay, for example, if I want to declare a variable called age, then just simply say, integer age. Okay, so it's kind of still understandable in each instruction. If you do not want to understand the whole thing, the more complicated things, but the individual statement is more like English. Okay, so that is third generation language, and the fourth generation language is more. Fourth generation language is more, you look at the statement, the commands more like English, very very similar to our daily language, except that the language, the statement is more precise and more structured. Okay, so examples of fourth generation language like SQL, R, right, for data analytics, and HTML. So those are examples of fourth generation language. Now, are there any fifth generation language? That is still under development. In the future, the fifth generation language, I believe, is going to be more like a diagram or picture-driven language. So basically, when we write a code, we do not need to write a code in, like an individual statement. Instead, we create pictures like ER diagrams or that, and then the diagrams will be executable. Okay, so that is the future of programming. All right, and the SQL consists of two parts. One part is called data definition language, DDL. The second part is data manipulation language. DDL is dealing with create, modify, and delete database objects. So database objects like tables, okay? Database tables will be objects. And the user accounts, that's also, and the views like queries you saved, okay? And the index, the index, right? So example of index is library index. So if, for example, if you go to a library to find your books, if you do not have index, just imagine how you can find your book. You pretty much have to look through every book to find your book, right? So in the worst case, if library has 6 million books, then you have to go through all 6 million copies to find your book title. But if you use index, the story is different. So first of all, index will tell you where is the book's location, which shelf, okay, and then which room, and then you just go straight to the place to find your book. So that same idea is applied to database. So database, have a lot of millions, billions of records, right? How can DBMS find the record you need? Okay, so basically it's using index. So each record is indexed, and you use the index to find the location of the record, and then go straight to the location to pick up the record, to modify the record, so on and so forth. So you need to use index always, okay, in the Oracle, in database, in any database actually. And then there's a triggers. Triggers is more like a program that is just like loaded inside a database. So we'll respond to some data actions. Let's just say some data like somebody's salary, employee salary is very sensitive data, right? So what if somebody trying to change his or her own salary, right? So you basically have to have a trigger to make sure that to monitor, whatever data has been changed, and then the log will be created. Who made the changes, at what time, and what was original value, what is the new value, all will be done by triggers. The trigger basically just monitoring all data activities and then create logs of those activities. Okay, so trigger is kind of programmed to respond to data actions, in other words. And then there's also, sometimes you may have like a stored procedures functions that will help you to automate some part of data management jobs. Okay, so basically those are just programs written in Java or written in PSQL, Transact SQL, those type of programming language saved in the database. And then, you can just run those programs inside on the database side to perform some kind of a systematic batch actions, batch transactions. Okay, and then there's some other kind of objects like an index, like a sequence, which can help you to generate auto numbers. The numbers 1, 3, 2, 1, 2, 3, 4. So auto numbers. That's called a sequence. And you can also create objects called the database links or synonyms. And we are going to go through some of this when we talk about Oracle database. Okay, so DDL basically is help you to just handle those handle the creation or modification or deletion of this database objects. And then the most important part of SQL is data manipulation. Data will be stored in tables, right? So we are going to use DML to create new records, to modify records, or delete records, and also retrieve records. Okay, so we are going to spend more time on this. Okay, and this one actually has more complexity than the first one. First one is just simply, most times just create, modify. It's pretty simple statements. All right, and this is how we create SQL tables. Okay, so a simple command, just create table. It's not case sensitive. This keywords create table is not case sensitive. Okay, just use small letters or mixed letters, does not matter. And then the name of table, and then you have a list of columns. For each column, you specify what kind of data. So that's a very simple type of command to create a new table. Okay, so this is an example. Suppose I want to create a new students. Okay, student has column student ID, last name, first name, state, city, and then each one, ends with comma, separated by comma, and the last one does not have a comma here, right? And the entire statement ends with semicolon, so indicating that is the end of the statement, okay? And the more general form of create table also include constraints. So what are the constraints? So the constraint, there are 4 types of constraints. Some say this one SID is the primary key, right? So you can indicate that the primary key along with that column. Or we can create another constraint, just separate the line to say constraint and indicate that that is the primary key. Okay, so primary key is type 1 type of constraint, foreign key is a second type of constraint, and then some other more general type of constraint will be like a check constraints. So basically you can check, say whether something, value is in the range or value is one of the possible values or something like those. So those will be check constraints. So generally, if you have a business rules, then you generally use check constraints to implement those business rules. Okay, and then there's some 4th type of constraint, simple ones. So sometimes the value must be unique. So for example, student ID must be unique, right? So you can say constraint unique. Okay, unique constraint. So that is also a type of constraints. The first 3 types are more common. All right, so here is the syntax for creating the constraints. So you each column name, type, and you can also put a constraint right at the place that the column must follow the constraint. Okay, and also you can just create a new constraint, create a constraint separately. So you can name that as a constraint, and then give a name, and then say what is constraint, the constraint name, and then what's constraint one by one, and ends with comma separated. Okay, and also entire statement ends with semicolon. Okay, so I listed only 3 types of constraints here, but unique constraint is not listed here. All right. Let me know if you have any questions. Okay, so here is an example of illustration. So I create table students. So those are the same columns we have, and now I add one more specification, that is a constraint. Constraint PK student, right? And then the constraint type is the primary key, and then I put parentheses and tell which one is the primary key. If you have multiple columns as a primary key, then column 1, comma, column 2, specify that. Okay, so list all of those part as one part of constraints. All right, and now what I'm going to do is I will start to write the code. So let's see how can we write the code. We could, let me see, I think I did not tell you to install text editor like a Notepad++, something like that. So we'll just use this. We'll just use SQL developer. So at this point, I hope everyone has SQL developer ready. Is that the case or not? Does everybody have SQL developer? So let's just type a code, write the code inside there, okay? So basically, okay. Somebody wants to say something? Okay, Does everybody have SQL Plus, not SQL Plus, SQL Developer installed on your computer? Yes or no?
Yes.
Okay.
Yes.
So the installation is pretty much the same as data model. It's just, after you download the zip file, drag that out, and then now you're ready to. Now let me just show you my version, and then we'll see whether you have any questions. Okay. We may go back to the PowerPoint to go some other slides first before we do that. Before we do these examples. So I'm going to open PowerPoint or open that data. What is SQL Developer? Okay. Okay. Do you see my screen? So first one, you get this this welcome page, right? So I do not need that. All right. So do you have that installed? Do you have, can you see, like, can you get something like what I show you? So I created some kind of links here. So I'm going to tell you create the links. Okay. So at this point, I can just delete the link, delete the connection here. Okay. So you should have something like this, right? Yes or no? Everyone?
Yes.
Okay. Anybody else?
Yes.
Yes. Okay. All right. Shane, are you okay?
Yes, it's just loading. It's being slow for some reason, but I have it downloaded and everything. Just waiting for it.
Okay. Let's wait. Okay. Ravi, you okay, right?
Yes, I have everything ready.
Okay. Good.
I have everything ready to go.
Okay. So I assume that everyone has this installed and working properly. So the first thing we want to do is we need to make a connection to Oracle database server. Okay, and this is just SQL Developer. It's just a client. We actually we used to teach something called SQL Plus, SQL Plus, which is more like a terminal type of the terminal type of a client to connect to server. That might be the case in the industry. People are still using that SQL Plus instead of SQL Developer. To install Oracle SQL Plus, you need to get Oracle client, which installation is sometimes a little bit complicated, and also you need to set up a connection or that. So it may not be user friendly. And also when you type commands, and if you have errors in the command, then you kind of very tedious to correct those errors in those commands. So I since last year, I think actually started. I'm not sure last year I did this, but at least this is probably last year. I forgot what I did last year. So before, definitely this is just pretty new. We are going to use SQL Developer to write SQL commands. Okay. So the first thing we want to do is to create a Oracle database connection to server. Okay. And then for that. So we will just say select, there's a connection here. So by default, you have new connections, right? So we're going to create a new connection. Okay. Now for the connection, first of all, let's give a name. I realized that the school, what is it called? VPN. School VPN is not really working. So we will have to use my own database called eCourse database, eCourse server for practice. Okay. But I have in my PowerPoint, I give you information on how to connect to school Oracle server. If your VPN is working, you can try that. But I just recently I could not establish any VPN connection to campus. Okay, so basically, may not be possible route for us to do the classes every day. So first of all, let's give a name. So suppose I want to make connection to ecourse.org. Okay. Okay. So database type is Oracle. That's the only type available. Okay. And then you're going to have a username, password. You have to have an account, right? So all of you have an account created on eCourse. Your username is same username for ecourse.org. Okay. So I will use my username here. eCourse. So if you log on to eCourse, right, you have to have a username, right? So that is the username you're going to use for this connection to eCourse database. Okay. And your password is going to be your last name only. Your last name. Okay. So I'm going to type my password. I'm going to tell you how to change that. Okay. How to change that password. Change it to something you can remember. Okay. And so that nobody can hack into your account. All right. So that's related to your account. So basically that information is given by DBA. So if you want to have an account with Oracle server, Oracle database, then they will have to give you account. Okay. Each account will come with certain privileges. For example, whether you can look up certain data, you can use their resources, or whether you can make connections. Okay, or maybe your account has like a DBA privilege to pretty much do everything. Okay, so those will be the account. Each account will have inherent privilege assigned. Okay, now we can make connections. So connection type, we typically use a basic type, or you can use so-called TNS type. So if you use TNS type, I think you do not have anything. But in my case, I have ecourse.org. So basically, what is that? That is, I have my Oracle client installed. Inside for that client, I already established TNS name, and that name has special connection parameters. So let's go back to this basic one. For the basic, so what do you need to connect to Oracle server? You need 3 parameters. First of all, you need to tell where is the computer's host name or IP address. Okay, so that basically is Oracle server is running on the computer, right? The computer must have a host name or IP address, right? So the host name for eCourse is simply just ecourse.org. Okay, host name. And then if you're going to use university's web Oracle server, then it's going to be like a CBA, not CBA, UACBA Oracle 2.unet.edu, something like that. Okay, so that is the host name. And then the port number. So basically on the computer, each computer there might be multiple servers, okay, multiple programs running. And each program will have a unique number, like a door number, so that if you want to connect to Oracle, for example, you're going to use port number 1521. If you're going to connect to web server, then you're going to use port number 80, right? If you're going to connect to the FTP server, then you're going to use port number 21, I think. Okay, so each program on the computer is going to have like a port number, like a door number attached. Okay, so for Oracle server, for eCourse, this number can be changed. Okay, when I do installation, but by default is 1521. So I use default one. All right, and finally, on each computer, on the one server, you can run not just one Oracle instances. You can actually run multiple Oracle database instances. So you may have one for production, one for marketing. You can have different database running on the same server. So in that case, you need to specify which instance you're going to use. The instance, it will be specified by instance ID like system ID or service name. Okay, so I will use service name. The service name for eCourse is ll7.ecourse.org. Okay, so you need those three parameters to make connections, and those three parameters can be combined into TNS name or through some kind of description. I'm going to show you that in PowerPoint. Okay, you can do that. You would use user approach like TNS or basic ways. Okay, so at this point, after you have entered those parameters, make sure you test it first. If you say success, that means everything goes okay. If not, that means there's something wrong with you. You get some kind of error message. So let me ask you whether you have all success or not.
It shows failure for me.
What do you say?
It shows the status as failure.
Failure.
It
Okay.
Yeah.
says invalid username, password, login denied.
Yes,
Login
this
not-
thing.
So username should be your eCourse username. Password should be the password should be your last name.
Yeah, we tried the same thing.
I've entered the same details.
You can say. Okay.
Yeah.
All right. Let me. Okay. What about other people? How many people have problems? Kelly, you have a problem? Ravi, you have a problem? Who else has a problem?
Yes, I am also having the same problem.
Oh, Chopra have a problem?
Same problem for me too.
Chen have a problem too? Okay, so so you guys basically get an error message saying that, saying you could not login failure, could not
Yeah, it
use
says
it.
invalid username, password, login denied.
Okay, that is interesting. So I don't see why so many people have a problem. All right, so let me see what can I do. Okay, so I am going to connect first.
Does it mean that I log in successfully if I see the new connection show on the left of my screen?
So if you after you save it, then next time you will see your connection stream there. You can just do that. But make sure you select basic, okay? We are doing basic. You do not have PNS. Okay, so make sure it's basic and then host name. So your problem, I guess, is mostly about username, password. So
I connected.
you're connected.
Yeah, me too.
You too.
Or says
Okay.
status success at least.
Okay. Success. So yeah, if you get success, that means you're okay. Okay. Pinchen, are you okay? Pinchen, are you okay?
Yeah, it shows on the left of my screen. Does that mean that I log in successfully?
So if you already made a connection, that means probably you're okay. Yeah.
Yeah, so I'm okay.
You're okay. Okay. So now I need to fix Ravi and Kalyani. What about Kilpatrick? Okay.
No, it still shows the same warning.
Warning. Okay. So I'm going to fix your three of yours connection. Okay. So I'm going to make connections. Okay.
Professor, for me it's working. Actually, I had to put first letter capital.
Oh, okay. So yeah, it's just I think it's a complete last name. Exactly, you put into eCourse. All right. So this time it shows that I get like a query builder on the right hand side, a blank screen. So that means that I log in successfully.
Yeah, it is working for me now.
It's working for you. Okay.
Yes.
It's working from me too. I think it just have to use like capital first.
Caps, yeah.
Okay. So then there's no problem. So now you save everything, okay? Save everything, save your connection. So next time you can open, just use the same connection. You do not have to do this process again. All right. So nobody needs help, right? Nobody needs help. Am I right? Okay. So now let me tell you how you're going to change your password. Okay. So first of all, this is how you change. You create a new password. You create a new account. Okay. So you just say, let's just type dash dash. That's a comment. That's just like a remark for SQL. Okay. So let's say create. Can you see my screen? Create a new account.
The words is a little bit too small.
Right. So let me see how can I make it bigger. Is there any way we can make
I think it's in the tool index
tools? Okay. Well,
in preferences.
preferences. Okay.
You can find code editor.
Code editor. Okay. You know that. Okay. Good.
Find font under it.
Font. Font. Don't see font. Okay. This is. You see font anywhere?
Oh, you should push the plus button beside the code editor.
Price bar. Oh, okay. Thank
Yeah.
you. Okay. Okay. So let's see. By default was 12. And let me try to change something here. Dialog input, display fixed width. Okay, let me see whether I can make a 12. Does that look better? Let me see. Still not right. Do it again. Okay, fonts. So this dialog input is not going to make sample text, selected the font size. Huh. That's not good. Dialog. So let's try and see that better. Let me see. So I need to get rid of this background. So what I should do to change the background? Change font format, bookmark, carry, completion, display. And do that. Format. So identify auto format. Does not have a way to change the background. I'm just trying to make a bigger fonts to see whether that make things better. Is that okay now? Kind of. Okay, so I'm trying to find a way to get rid of this background. So here I create a new say create a new account, and this is how you create. So create user, okay, and then you type a username. So suppose I want to create a new user called Scout. All right, and then you say go to the next line, say identified by the new password. Let's say Tiger, right? And then the statement ends with semicolon. And actually, when you actually DBA, you want to create a new user account, but since you do not have a DBA privilege, so this you cannot run this. Okay, you cannot run this account. Okay, you cannot run this statement. Okay, now let's say how do we change modify say password. So this is what you need to do. Okay, modify password. So you're going to say alter user Scout So in this case, you can only identify your own, okay? So I'll use Scout as example, okay? And then say identified by, say, whatever new password. Okay, let's say if I want to create, say, a password called not tiger, maybe like a wolf, okay? Wolf. So this is how you can change your password. So make sure you replace the username by, you can only do that for your own, okay? You cannot change anybody else's password because you are not DBA for this database, all right? And after that, replace the wolf by your own new password, okay? Is it clear? Okay, so after that, so suppose I want to run this statement, I will select this statement first and then press this run statement button. So in my case, the Scout password has been changed. So if I want to change that again back to Tiger, okay, and then I will select that and then run it. Okay, so password is changed again. Okay, and if you want to delete the password, delete your account, so you will say drop account, and this is how you drop. So drop user, say Scout, semicolon. Okay, so then that's how you do it. Just if you press, so you can, so in this case you cannot drop anybody's account. Okay, cannot drop anybody's account because you're not DBA. So basically, this is how we deal with user accounts using these 3 DDL statements. All right. No problem, right? Okay, now let's say I'm going to use one of the examples we did to create the tables. And then after that, after we create a table, we run this table and then we'll look at some other objects, okay? So let's say we can just use this one if we want. I don't think this was your homework. So we can just use this one as example to create the tables. How's that? Okay, so let's use this relational model to create SQL statements. Okay, so let's just say create what is the name? What is the name? There's a patient appointments. Tables. So this is same as implementing. So when we say implement this relational model, we basically just write SQL statements to create those actual tables. Make sense? All right, so now let's do it. Okay, so we start with a patient. Okay. Create table patients. Okay, left parentheses. And then we list the columns one by one, and then constraints one by one. So patient has 4 columns at this point. As what is it? PID. Oh, actually, you know what? We cannot create a patient table first because patient table has a foreign keys. So we should create a table without foreign keys first, so that doctors has no foreign keys, right? So we'll create that table first. So we'll create table doctors first. Okay, so you'll know why. Okay, just a second. So doctors has 3 columns: doctor employee ID, last name, and field. So doctor employee ID, the name of column, and then the data type. What kind of data for employee ID? So let's just say I will use number. Okay, and then just say maybe 3 digits number, assuming that you have 9 like 999 doctors. Okay. Okay. All right, and then you can also specify simple constraint, like say, yeah, employee number must be required to have value. So that means not null, not null. Do that. Okay. Those constraints we really, we can just, instead of creating separate constraints, say this is not null. We can just do this. Okay, say not null. Okay. But what if you say that the constraint is if a column can have a missing value, then you say null. Okay. However, by default, the column will be null if you don't say not null. Okay. So we'll get into that. So for here, or just not null. Okay. And comma. Now let's do the second column, which is employee last name. Last name. So let's say for employee last name, I'm going to have, for doctor last name, I'm going to use char and then 45 characters. Okay, and that's not null, right? Because if you look at here, this is a star here, L name, okay, not and the field. So L name, let's change that. Okay, and the comma, and then go to next row, next column, which is a field. Field is just like a name of the field, then like a dentist. What dentist is not considered is field. People are dealing with different kind of subfields of medicine. Okay, so we'll just use char here. So give 25 characters here. Okay, and also that's not null. So that is what the star means, okay? That's required value. Okay, and next, after we have all those columns listed, then we consider primary keys and the foreign keys. So I'm going to do that in one shot, and later I'm going to tell you how you're going to add constraints, drop constraints later, okay? So let's say if I have those primary key, foreign key already in place, why not just create them in one shot? Okay, so here we just have primary key, okay? So EID primary key. So now I will create a new constraint for that. So we'll call it constraint. Okay, and then name of the constraint, let's say PK, and then just say DOC, doctor, okay? Doctor's constraint. Okay, and then the type of constraint is a primary key. And then parentheses, you specify which columns are primary keys. Okay, if this is everything, then we will just go to the last line, parentheses, and assign my column. There we go. Okay. Now, at this point, if you want to say whether there's any errors here, we can just select this statement. So if you mouse over any place in the statement, okay, you don't have to select everything. Select that. You don't have to do that. You just put your mouse in the place that you want to run, and press this run button. Then that statement should be executed. Say my table doctors created. If you get an error message, it will tell you which place you have errors. Okay. Everyone.
I tried to run it and it says no privileges on table space, no privilege to allocate an extent in the table specified table space.
Oh, really?
Yes.
What about others?
Yes, I'm also getting some error.
Those are getting this error?
Yes.
Me too.
Okay, let me do this. That's a little bit strange. I think I already gave you. So let me go to create a scripts again. Let me take so you know what? Let's take 10 minutes of break. During the break, I'm going to fix that issue. Okay. So let's take a break until 8:17.
Okay.
Let me pause. Schedule. Okay. Okay. All right, let's continue. So we create a doctor's table, and then let's do patient's table next. So patient table is using doctor's ID, EID as the foreign key. So we're ready to do patients. Okay, so let's do that first. So create table, patients. Okay. And then it has 1, 2, 3, 4 columns. So PID, let's say patient ID. Let's just say we are going to use numbers also. The number 7 patients, 797, and that's not null. Okay, because ID is always not null. And then name and the phone, patient name, P name. Let's use child 45, and that is not null also. And the phone is child, we use 14 characters, and that is null. So basically that is optional, right? So optional we could just we will just say null. Null does not mean that the value is missing, but it can be missing. Okay. So if you do not specify that you don't have null, then that's just by default is optional. Make sense? So let me put text here. So by default to null. Okay. All right. And then next, we have a primary doctor. Prime doctor. So the primary doctor is a foreign key, which is essentially the employee ID. And this is a place we are using invoking so-called referential integrity rule. That is the data type and the size, data type's number, size 3, for foreign key must be matching the corresponding primary key column. So here we have to use number 3 also. Okay, so that is a forced referential integrity rule. And this foreign key is not null, so it's required. So we have to say not null. Come on. So after we have all the columns, then we are ready to do constraints. So this table has basically two constraints. This is a primary key and this is a foreign key, right? So we're going to create constraint. So first PK, and let's say PAT, patient, and then primary key is a primary key simply is a PID. Come on. So now let's create another constraint for foreign key. Constraint, then FK, patient foreign key, and the references to doctors. So I will go into this naming convention. That's my naming convention. So basically, I name that type of constraint, and then the beginning table, and then the table from which you get the primary key, right? So it does not matter. You can use different kind of naming convention, but just make sure that is descriptive, is easy to understand. And then you say foreign key, okay? And then you specify which foreign key, which one is foreign key. In this case, it's a prime doctor. It's a foreign key, right? Prime doctor. Okay. And then after that, you will say references. Reference to which table this foreign key is duplicated from doctors, right? So you specify that name of table, doctors. And that's it. That's it. And then sometimes people pay, what do I have to specify which ones is a primary key, EID, for example? You don't have to, okay? It's just because when you create a table doctors, you already specified that EID is a primary key, right? So it's just reference to table doctors, actually doctors. And that's all you need, okay? So then this table has only these two constraints, and we can end it. Then parentheses, semicolon. So now we have a second table. So now let me see whether my scripts has already arrived. Yeah, it's arrived. Let me try it again. So let me okay, scripts. So this time I'm going to give you unlimited table space. Okay. Now create one of the tables again to see whether it is working this time. So just create like a doctor's table, patient table. Is working? Yes or no? Are you there? Hello, can you hear me?
Yeah.
Yes.
Is it working?
Yes.
Yes.
Okay, good. So basically, you have a limitation with some table spaces. That was the reason. Okay, so then this problem is solved. And now you can just select both of them to create these tables. So you get an error message. You maybe say that table already exists, something like that. Select both and then run the statement. Press run start. Run statement. Get it?
Yes.
Is it working?
Yes, it's working.
Okay. So when you, for example, if you say, in my case, if I run this statement again, create doc table again, I'm gonna get an error message saying that the table already exists. So let's say the name already exists by existing object. So what I did, because you cannot create two tables with same name, right? So usually you can just create, if you want to create scripts to be executed multiple times, you can just drop the table first. Drop table doctors, okay? Before you create it. And do the same thing. Let's say drop table patients. Like that. Okay. So then you can run these statements anytime you like. So they will be all something wrong. Did I get some kind of error? Okay, let me do it again. So here. Okay, table created, patient. First one was arrow in starting line 41, drop table patients. Table does not exist. Okay, that's because I do not have the table to begin with, so now let's do it again. Okay, so both tables are created, dropped, created, dropped, created. So it should have no errors. Okay, so it should be, so if you're going to create scripts to be executed without error, and that's how we do it. So that's how we delete a table. Okay, sometimes if you drop a table, that table, for example, already have like a primary key, foreign key reference. Oh, okay, actually this one has a problem. So we cannot drop a table this thing because this one has a foreign key reference. Okay, so we have to do this. We have to say create drop table, cascade constraints. So if there's any constraint, like a primary key was used by some other places, then then just drop those constraints to cascade. Delete the constraints also. Okay. So now it should be clean. You see the problem? Yeah, because when we're trying to delete the table doctors, but doctor ID was referenced by patients, and that was preventing us from dropping the table. Okay, so if I put put option like a cascade constraints, then primary key, foreign key constraints will be deleted when the table was dropped. Okay, it's kind of dangerous. Just let you know that you don't do that with your production database. Okay. All right, so now let's continue. Let's see whether there's any other tables that we need to pay attention. So we did doctors, patients, and now let's try to do which one? Before we can do appointments, we have to do visit, right? Because there's a visit as foreign key for appointments. So let's do visit next. Okay, visit has a VID, VDate, and a patient. So create table visits. So it has a VID. Let's just use some kind of a number for that. Let's just say the number is going to be how many digits? So we have the concept of seven digits for patient. Then each patient may have a couple of thousands visits in the long run. So I may just add like maybe 11. Okay, and not now. Okay, and then patient visit date, VDate. That is date, Oracle data time. So for Oracle date, the size is fixed. So there's nothing you can do for the size, just type. Okay, so Oracle visit date is required. So that's not no. And then finally we have visit with patient. So patient is foreign key, duplicating the patient ID. So make sure you follow referential integrity rules here. That should be number 3, or not this patient. Patient is here. Patient is PID, so it's number 7. Okay, so we have to use that format type as number 7, and it's also not a null. Okay, those are all the columns. Now let's do primary key, foreign keys. Okay, primary key VID. And patient ID, patient is foreign key. So let's do that quickly. Constraint. Okay, PK, visit. Okay, say primary key, which is a VID, comma, and then constraint. And then for FK, foreign key, visit. And this foreign key is duplicating patient, right? So I will use PAT here. Then we'll see foreign key. Foreign key is patient. So that's column indicating here. So for references, the name of table, which is the patients. Okay. All right. Now at this place, let's say I want to also implement a business rule. The business rules will be stated as another constraint, like check constraint. So the constraint will basically say that this visit date, the visit date must be, for example, after 1920. Okay, so just in case that no visit date happens before that, so the hospital or clinic was not established before 1920. So we can create another constraint called check constraint. So this is extra. Okay, so I will say check. Okay, then say check date, check VDate. Okay, and then say check, and then actual constraint I'll put inside the parentheses. So we'll just make sure that the VDate is after, right? After certain date, after 1920. Okay, so this is how we specify Oracle date, single quote, and then specify 2 digits for the year number, for the day value. So let's say 01, and then first 3 letters of a month name. So let's say January, okay, and then and then 4 numbers for year number. So 1920. So this is how you specify Oracle date. It's a single quote, and then day value, month name, and also year number. Okay, so this is the check constraint content. Okay, so basically, when somebody insert data into visit, and this rule will be followed, will be enforced. Okay, just make sure that when somebody put like a visit date, that visit date must be after this one. If it happened before that by accident, then this data will be prevented from being entered. Okay, so parentheses, semicolon, finish. Okay. Now let's do. So we did a visit. Now let's do appointments. So we're ready to do appointments. Okay. So appointment has 1, 2, 3, 4, 5, 6 columns. Okay. So it has foreign keys, 3 foreign keys. Okay, and the 1 primary key. So we're going to write more of that. Let's do appointments next. So let's do that. So create table appointments. Parentheses. So appointment have, let's say, it doesn't matter which order we create. We can just follow the original order. So first one, we have a patient. Remember that is a foreign key. So make sure you follow referential integrity rule. So that is actually the patient ID. So which was number 7, data type and size. And whether that's required or not, let's take a look. It's required. So we will say not null. Okay. Make sense? And next one is AID, appointment ID. So appointment ID, let's just also use a number, maybe 11, okay? And that is not null, of course. Okay. And then a date and the reason, both are required. So appointment date, so that is data time, okay? And not null. And the reason, that is text. And that could be potentially long text. So we use vocab. So actually, Oracle supported 2 different kinds of vocab. For Oracle database, vocab 2 is kind of like a more optimized vocab. So generally, vocab is available for any database, but for Oracle 2, for Oracle we use vocab 2. Okay. So let's say I specify 1,000 characters. Just in case we have long text to write. But if a reason does not take that much space, then remaining space can be saved. Okay, so it's like a char. Char basically, if you say char 1,000, then every page, every appointment is going to take 1,000 characters regardless. Okay. All right. So now let's say this is not null also. All right, and let's see what else here. A reason, and then we have a doctor and a visit. Doctor. So again, that is employee ID. So that remember that was number 3, right? So we'll have to make sure, is that not null? Is that required? Yes, it is. Visit is not required. So doctor is. So that's not null. Okay. And the visit, and that is visit ID. So we have to make sure that it's matching visit. Okay, visit was using number 11. So we have to say number 11. Okay, and that is null. So we will just leave it empty. Leave it as default. Okay, so we have all the columns created. Now let's create constraints. So let's say constraint. First constraint is going to be primary key always. Not always, but just just make sure that you follow the order. So this is appointment, APP appoint, okay? Appoint, and then primary key, which is AID. Good, that's simple. And then we have a constraint, 3 constraints, 3 foreign keys, right? So first one is a patient, and then FK. And then this is a point and the reference to patient. Okay, and then foreign key, and that foreign key is the patient. Okay, and then the references to patients. Okay, next. All right, and then next we have a foreign key for doctor and a visit. Constraint FK point to doctor. Foreign key, and that is a doctor. So make sure you use exactly same name, same column name you listed. The references with doctors. Okay. Finally, constraint FK a point, and this one is the visit. Okay, and the foreign key, and that is the visit. Okay, references, visits. Okay. So all foreign keys are referenced. All foreign keys are created as constraints. So this table has too many foreign keys. Okay, and parentheses close. Okay. All right. So let's see whether we have everything. So we have two more actually. We have a vital sign, and also we have a junction table. So let's do vital sign first. Vital sign basically have visit as a foreign key, so we are ready to do that. So create table vital signs. Now, if you have questions, you can just ask, okay? I'm doing, because most of the stuff after the first few tables is pretty straightforward, so I do a little bit fast. All right, so first one is vital sign VS number. Okay, so I will just use simple number, like say, usually you may have like a couple of maybe 2 digits, 99 vital signs at the most, right? Okay, and then there's not null. And then vital sign name, I will just use say child. So that would be some kind of names. So just do maybe 40 characters. I hope that's enough. And that is not null. And then vital sign value. Anybody wants to talk to me? Okay, so value. So the value is what? So it may not be numbers, right? So in general, maybe like a text. So we use char also. So let's say char, maybe put more characters. Okay, that's not null. And then finally, we have foreign key, which is a visit. Okay, so for that, we have to make sure that it is following this primary referential integrity, which is data type size matching. So that is number 11 again. Okay, and is that required? I think it is required. Okay, so that's all the columns for the table. Okay. See that 4 columns, and now they're all required. And now we have to define primary key and foreign key as constraints. Okay. So we have one primary key always, constraint, and then there's a PK for vital sign, okay? And then primary key. So the primary key in this case consists of 2 columns. So VS number, that's 1 column, and the second column was the visit. Okay, so those columns. So if you have a primary key, foreign key consist of multiple columns, just simply use comma to separate those columns. Okay. All right. And then we have a constraint foreign key. Constraint FK VS, and that is reference to visit. Okay, foreign key. and that is visit. References. The name of the table is visit. Okay. All right, so that's everything, and finish it, semicolon. Finally, let's one more table, then we are done, and then we can go back to PowerPoint to talk about a few more things. Okay, so let's see the last one, that is junction table, which is a doc visits, doctor visits. So it has two columns, two foreign key columns in there. Okay, so let's do that. Doctor and the visit. So create table doc visits. So it has doctor, so that's a foreign key. Doctor was using how many? Was using number 3, right? That's employee ID, so it's not null. Okay. And next one was visit. Okay, so visit is number 11. So that both are for primary foreign keys. So we have to match their corresponding primary keys. So not null. Okay. And then that's it. Those are the only two columns. Now let's do constraint. Constraint PK. The first, this is doc visit. Okay, let's say doc visit. And then primary key. So this time primary key also consists of two columns, doctor and the visit. And this table has two foreign keys. Those doctor and the visit are foreign keys. So we have to create them separately. FK, EV, first one reference to doctor, doc. Okay. And then say foreign key. Foreign key. And then and the foreign key we will with doctor, right? Doctor. References. Name of table is doctors. Comma. Constraint again. FK, EV, and this one is a visit. Foreign key. And visit. Okay. References. To visits. The name of table. And that's it. Semicolon, finish it. So we implemented the whole thing. Implement the whole thing in this relational model. Okay. Any questions? Anybody? No question?
No.
Okay, if there's no question, let's try to create all the tables. And then you may have some kind of errors. You can just make sure that you correct those errors. We may not have time to correct all of errors. Just make sure to create 3-4 tables. Then if there are more errors, then we can just use outside the class time to correct. So here table view doesn't exist. So we're trying to do which one we're trying to do here. Arrow, line, command. So we have many arrows here. So let's see what errors we have. Visit. Let's starting from the beginning. Okay. So in my case, patients was okay, and then when I create a visit, I have an arrow here. So let's see what errors we have. So table view does not exist. So which one is, so that's basically is saying that when I create the visit, let's go to visit, okay? Go to visit. So now let's see, visit is reference to patients. I think I misspelled patients. Okay, so basically saying that table name does not exist, patients does not exist. I think that's the case. So now let's select this, just run this and see whether it works. Okay, so this visit is now working. After visit, now let's do the patient. Let's run the patient next. Okay, so now I have patient has a problem. So that what is that? Appointment has a problem. So appointment is saying that missing keyword. So sometimes it may not be very it may not make a lot of sense.
I think it's like on reason worker, it's not null.
Reason, okay, or not
Not
null.
null.
Yeah, thank you for that. Yes, not null. Yeah. So let's do it again. Run. Okay, so pages appointments is created. Okay. Now let's do vital sign. Vital sign is okay. Dog visit. Dog visit is okay. So now all my tables are created without errors. What about you guys?
No problem. All tables created.
Table created, no problems?
Yeah.
Okay, good. Nobody has errors, right? That's good. So
Yeah, no
basically,
problem.
so this is the place when I use SQL Plus, I always have the handle. So what if you have errors, then you have to go back and copy paste all that. And actually there is a special system that allows you to do inline correction that basically will take a couple of days to learn that. So basically if I use this one, I don't have to do that. All right, so very good. So we basically create a bunch of tables. So now the question is, the next time when you come back to look up, say what tables do you have, especially when you use SQL Plus, there's like a terminal type of a client to check, to look up to see what tables you have, all that. So now I'm going to tell you how we are going to use so-called meta tables to look for information on the things you already have, like a database objects like tables, users, all that. Okay, so every time when you create a new table, the table information about the size, all those will be stored in a table, meta table called user underscore tables. That is a meta table. So let's try to say what is the structure of that table. So it's a DESC describe, okay? Describe. And that is not SQL. Actually, this is just like a command relevant to Oracle only, okay? So describe user tables. So let's run that, okay? So it will give you a list of columns available to the table. So for example, the very first column of the table is called the table name, right? And the second column is called table space name. So table space is more like just like a folder for holding tables, okay? So you make a logically put those different set of tables in the one place that's called table space, okay? And all tables are put inside, your tables are put inside called, or table space called users, okay? So based on this, I'm going to, based on the first column actually, first column called column name, table name, I will be able to find what tables do I have, okay? So that is command, okay? Command, which is describe table structure. So in this case, we're describing the table structure for the metadata, for meta of the meta table of user underscore tables, okay? So we can use the same command to describe some other things. For example, if I do describe doctors, okay? So remember, we already have a name of table called doctors, right? So if you run that, and then you will get, what the columns you have in that table. So EID, not null, number 3, all that, right? So you can apply that to look up describe data table structure of doctors table. Okay. Now after we describe user tables meta table, we found that there's a column called table name. So we can use that to find the name of a columns, name of the tables I have. So this is how you do it. You do select, okay, and then table underscore name underscore name, okay, and then say from user underscore tables. The name of the table. So basically what does this do is just looking at, just retrieve the user underscore tables, table name column, the first column, okay? Just look at the entire column data. So if your cursor is inside the statement, and if you run this statement, you'll be able to get all the tables you have. Okay. So far I have six tables: doctors, patients, visits, appointments, privileges, and log visit. And then if you go over that user table again, that basically has more columns. So basically it tells you, what percent of data, what percent of the table has, data has been used, and what is in percent of space has been used, and how much space left, all that. So basically that, the users table, meta table, as a meta table, organize all the information about tables you've just created. Okay, so after we have that, now after we have a list of tables, now we can just say suppose I want to say what tables, what is the structure of the appointments table. So we'll just say describe appointments. Okay, and run it. So it will tell you that this table has a bunch of columns, whether that the column has a missing value or not, and the type of value and the type of data for the column. So have patient ID, appointment ID, appointment date, all that. Okay, so basically give you all the structure of the table. Now, if you want to see what kind of data, at this point the data is empty. The table has no data, right? So if you want to look at data for each table, there's a simple command, just simply select. Okay, you can select particular column, say for example, patient from the name of table, which is appointments, to look up the column. Okay, it's just like what we did with look up this column, users table name column. Okay, so you can do that. Okay, so we have no data in there. Or if you want to say all the columns, then you say select star from appointments. Okay, and that is the DML. Okay, we'll be learning that later. So just simple ones. So this one we look at the entire table, everything inside, all rows. So we have no data, so basically it's just empty. Okay. Okay, so that's how we're looking up data table name. So what if you want to find out your constraints? So remember we have a lot of constraints, right? So let's describe this table called user underscore constraints meta table. Constraints. Okay, let's describe that. And the table has a bunch of columns too. So for example, it has owner, who owns that, and then constraint name and constraint type. So let's just look at these two columns only, okay? Constraint name and constraint type. And also table name, we have table name here too, okay? So let's look at the three columns here. So we do select, constraint name, comma, constraint type, and table name. Okay, from user underscore constraints. Okay, so we're looking at meta from this meta table. We look at three columns, and then will give us the constraint name, type, and also table names. So basically, that's useful information about about each constraint. So let's run that statement. So here you are getting a lot of things, but some of them are not making any sense. So for example, things like sys, okay, and then constraint type does not. So basically, C means a check constraint. Okay, check. And then this name, because when we create those names, like for example, for doctors, there are certain columns have to be not null, right? So those are because we did not name those constraints explicitly, the system just automatically create a name for those constraints. So for example, all the not null constraints, we did not specifically name it. And then for others, let's look at continue. So for example, check visit, does that make sense to you? Does that ring a bell? So we name one constraint called check date, right? So basically that's a check constraint, and that we attach to visit table, right? So that is explicitly named. So let's continue. We can find some other constraints. For example, foreign key, that's a reference. R means reference type of constraint, and that's attached to appointments table. And then continue. Okay, let's see. PK, primary key P. Okay, so a constraint type, and that was attached to doctors. You see that? So unless we explicitly name a constraint, otherwise the system will automatically create a constraint with a name, with arbitrary name. So for example, doctor, this doctor number, this is not null, right? So this is actually a check constraint because we did not explicitly create a constraint for this. We just attach the constraint to the column. So system actually will create a constraint for you. Okay, so it is important that you create a constraint explicitly constraint for primary key, foreign key, and for some kind of important business rule constraints, like what kind of value are acceptable to the columns, and those constraints you name that will give you opportunity give a DBA opportunity to remove the constraints temporarily in case they need to do some kind of data maintenance. And with the constraints, they will not be able to do anything. For example, copying data or that. But then, in those cases, they may just want to temporarily remove the constraints after data copied, saved, then they will put the constraints back. Okay. But if you do not have a name like those constraints, so it will be very difficult for DBA to recognize those constraints. All right. And regarding constraints, the next thing you want to do is, how do I know that which constraint is attached to which columns? Which constraint is attached to which columns? For that, there's another meta table called a user constraint columns. This one. User underscore counts and columns. That table will give you information on which constraint is attached to which columns. So let's run that statement, and then we'll get a smaller table. So basically, this gives you constraint name, table name, and a column name, and also have a position. Okay. So let's say I want to get name, table name, and also column name. Okay. So let's run that statement. Select constraint name, table underscore name, and then column name. Run. Question from user counts and the columns. Okay. So we select those three columns to get a constraint name, table name, and a column name to say which constraint is tied to which columns. Okay, so let's run that statement. All right, so we get a lot of things here. So for example, PK visit, PK is a primary key for visit table, right? So there's a vital sign table, and there's a visit number, that's the column attached to that. Okay, and then this one is probably not null column, not null constraint is attached to visit name, visit value of that. Okay, so this table will give you information on which constraint is attached to which columns. All right, let's say we have about 10 minutes left. Let me check the PowerPoint to see whether there's anything. So we're trying to use a DDL example. We did just one example, so this we did not do the three examples here. Okay, so now let me run this PowerPoint slides to see what. So we talk about referential integrity rules. Okay, referential. We have two rules. Okay, the first rule we just introduced today, that is field type and the size for foreign key column must match the corresponding primary key column. Okay, so without that, your code cannot be even created. You get an error message. Okay, so foreign key columns, but foreign key columns can have different names. Remember that. Okay, so that's only data type and the size. Data type and the size must match. But the foreign key columns can have different names from the corresponding primary key columns. Okay. Oracle is a DBMS. Okay, so DBMS basically the job is to help you to organize the data. Okay, so defining database structures. Okay, and then also going to do database manipulation. So basically, we are going to use that to retrieve data, modify data, all that, and also secure database. Okay, and so you make sure that the data will not be arbitrarily hacked by other people. Okay, prevent unauthorized access, and also have a rule for concurrency control. This is about situation that if you say so suppose 2 or 3 users are trying to modify same piece of data. Okay, so then the concurrency control must be in place. So that only one person can only so they should only allow one person to update one piece of data at one point in time. Okay, only after that one person is finished, after log, so the log will be released, and then the second person can go on to make changes. Okay, otherwise you can just imagine that 3 or 4 people, they all override data each other. So then the database is not going to be going to have integrity. Data is going to be damaged. Okay. This is about the so-called database design and management issues. So for design, we trying to reduce redundancy, right? We talk about that at the beginning of the class. So if you have too many duplicates, you're going to have a lot of problems. Okay, so data inconsistency is going to be one of the problems. Okay, and data integrity will be also a problem with data redundancy. And then there's also so-called when you're dealing with DBMS, so atomicity control is also important. Atomicity, just say we have long transactions. Okay, you have to make sure that the transaction is all complete successfully, 100%, or not at all. So you do not want to leave transaction partially finished, partially complete. Okay, so that is related to so-called atomicity control. Okay, and the concurrency control we just said, and the security, you understand that, just make sure you prevent unauthorized access. Okay. All right, so we talk about this Oracle connection. So basically, if you want to use DNS, the TNS names to make a connection, so you have to install Oracle client, and then inside, after you install the client, you get something installation. Suppose in my case I installed into app folder, an Oracle, and then product, and then specific product client network. Inside the product, you're going to have a folder called network, and then admin folder inside a subdirectory. And inside that, you're going to have TNS names. Okay, that is the place you're going to put, connection configuration to link to DNS names to link to another remote database. So the link is going to look like this. Okay, so you're going to have a file. The file will look like this. Okay, so in here, this description is equals.org, right? Basically, that's what you see. That if I use TNS names, so remember I use TNS, and then I show equals, right? So that basically the equals will tell you that I have the address, which is a host address, and it's a port number, and also the service name. So basically, all 3 parameters are embodied into this so-called description. Okay, so that is a standard approach to making connection, to make a connection to Oracle. Okay, and then this is the basic one we already did, and we tried the basic approach. Basically, just provide 3 parameters in 3 boxes, but that's only available when you use SQL Developer. If you use SQL Plus and other clients, then this is not available. Okay, so the previous approach is the only way to do it. Does it make sense? Okay. And we learned how to create new users, change password, and drop users. Okay, we did that. And then we learned how to implement a relational model. That's basically we create new tables, and then we learn how to drop tables. but we have not learned how to change tables. Probably we have to do that next class, okay? And then we learned how to list tables. All the tables you have, we use a meta table called user underscore tables, and we learn how to describe a particular table structure. Okay, just describe the name of table. And then we learn how to look up the constraints, including tables and the columns attached to those constraints. Okay, and I'm going to stop here. So basically, we have a few more slides unfinished that's related to how do we going to modify existing tables and also to create other type of objects like sequences, database links, okay, and the synonyms, all that. So I am going to just do those in next week class. Okay. Any questions? Anybody?
None here.
Okay. Homework will be posted by. I will try to do that tonight or maybe latest tomorrow morning. Okay, the homework will be due next Wednesday, before the class. All right. I think online question homework. What is that? The hands-on questions has been already posted. It's just the online question, multiple choice questions. I need to prepare and then post by tonight or tomorrow morning. All right. If there's no more questions, I will. Oh, by the way, next week, my plan is to continue hybrid classes. How many of you want to go back to the classroom? Anybody wants to go back to the classroom?
I'm gonna continue being online.
You continue online, okay? What about other people?
Hello.
Yeah, I'll continue online too.
You want to do online?
Yeah.
Okay. Anybody want to do outside the next class?
Professor, I'd like to attend in person.
You want to attend in person, okay?
Yeah.
Okay. Anybody else?
I think I will as well.
Okay. All right. So as long as I have people to do in person, we will do hybrid. Okay. So let's do a hybrid in next class. I think hybrid in person will give you more opportunities to just give you more different kind of experience. I think if I was student, I would prefer on-site. Okay. So that's good. Everyone have a good night, and we'll see you next class. Let me know if you have any questions. Okay, just drop me email, send me email at any time. I will get back to you. Should be within few minutes. But sometimes if I'm doing teaching or something else, maybe a few hours. Okay. All right.
Thank you.
You're welcome.
Thank you.
Sure.
Good night, everyone.
Good night.
Bye bye.
Dr. Liu,
Yeah.
may I ask questions about the test online, the
Yeah.
assignment?
So again, you have a question about
The assignment, the online test.
online quiz? Yeah, online quiz will be posted by tonight or tomorrow morning, the latest.
Oh no, I mean I have questions for the test for the past week.
Oh, well, the existing one, the previous one? Okay, so which one you have questions?
The one about banking systems and the one about e-commerce system.
Okay, so let me check that. Okay, just a second. So let's see, when do I still do you still see my screen shared with you, or it's already stopped? Let me see.
It's still on the PowerPoint.
Still on PowerPoint? Okay, so that means I have not stopped that yet. So let's see what's going on here. Just do cancel that. Okay. Stop recording first.